Good morning, everybody. Welcome to the Chesterton Channel. I'm glad that you all could make it here, and I'm Ingo Stenner, and I'm actually joined by Hans Decker. He's our product line manager for mechanical packing, gasketing, and also live loading. How are you doing, Hans?
I'm doing very fine, Ingo. Good morning, everybody. It's very nice to be here, and thanks for joining.
Hans, I believe you have something very exciting to talk about today.
Yeah.
It's called the AMS unit, and I believe it has nothing to do with electricity. Is that correct, Hans?
That's correct, Ingo. AMS is really a new innovation from Chesterton. AMS stands for Advanced Mechanical Packing System, and it's really a new development where we use pneumatic force actuators, pneumatic actuators that we place on the gland of rotating equipment to supply the sealing force on packing.
Means you're talking mainly about rotating equipment.
Rotating equipment, so we are able to reduce very strongly the maintenance on this type of equipment and extend the life of the packing.
Fantastic. Can you give me an idea about packing itself?
Yeah, packing, compression packing is used already for a long time in equipment, to seal equipment. It was in essence already used in the steam age to seal rotating and other shafts. But it doesn't mean that today this is an obsolete technology. It's still widely used in many industries because it has some very specific advantages compared to some alternative methods.
Can you give me an idea what type of industry you actually use packing itself, and what equipment do you use it?
Yeah, so packing is still widely used in many industries, but there are as well some types of equipment where packing is really the best available technology.
Okay.
So, and we're talking there, for example, about digester equipment in the pulp and paper industry. We're talking about large slurry pumps, so severe services equipment. That's really where packing is still widely used because of its advantages.
When you talk about large slurry pumps, what size are we talking about? You know, what is the shaft size typically you use packing in there?
Packing is really used on practically every size, but one of the advantages of packing, besides the fact that it fails non-catastrophically, so some other alternative sealing methods, they fail catastrophically. So actually at some point they just break and they need to be repaired. Packing starts to leak slowly. So that gives the operator some time to plan maintenance. But really, packing is in some types of equipment, the best available technology. And for example, specifically in this type of slurry pumps, that is very important.
Okay, but I guess we're not here if there were not any disadvantages of packing as well.
Correct. Of course, packing has some disadvantages as well. So one of the disadvantages, and that's as well the reason why it's been replaced in many rotating applications by alternative technologies, packing always needs to have a little bit of leakage. So leakage provides lubrication, it provides cooling. As well, the life, the MTBR of packings compared to some other technologies is relatively short.
Why?
Because of the technology itself.
Okay.
So, and another disadvantage is really that packing needs to be retightened on a regular basis. So it's very maintenance intensive.
Do I understand that right? You know, packing itself can relax. So it means you need to retighten the packing so that you actually always have the right pressure, so that hardly any, again, you know, you said there need to be some leakages, but hardly any material will actually go by the packing. It will seal the rotating equipment.
So what happens is packings are made from fibers, braided fibers, and they're really filled with lubricants. And these lubricants, they basically, as the word says, it provides the lubrication. So what happens is when we install packing in rotating equipment, there is wear of the packing, but as well these lubricants, they are being squeezed out of the packing to provide lubrication. So there's really volume loss taking place, and the volume loss, when the packing loses volume, leakage occurs. So this needs to be compensated for, right?
It means the operator needs to actually go down to that rotating equipment and physically has to tighten the gland so that the packing actually will seal again.
Exactly. So packing is very maintenance intensive. And if we look on the graph here, we can really visualize this. You can really see that on the vertical axis here, there is actually the force on the packing, and on the horizontal axis, that's really the time. And what we see here is, first of all, that the packing is retightened in the beginning, and then it relaxes really. And then after time, the packing relaxes, loses volume, and we see that the packing needs to be retightened. And it's going to be retightened to a certain force that we can see, and this happens over time numerous times. So the first issue that you see is very maintenance intensive. The other issue that you see here really is the peaks here. What people tend to do when they install and retighten packing, they give it some extra force. So because they think, we're going to give some extra force, so the next time that I need to retighten, then it's going to be later.
So that it's really sealing, you make sure that it's really sealing, and you don't have to go back the day after to actually do it again. That is the intention. It was a good intention of the operator, I guess.
But what actually happens is you create some extra wear on the packing. You squeeze extra lubricant out of the packing. So this actually shortens the life of the packing.
I understand. When you have a big leakage, what happens then when you have a leakage, when the packing is relaxed?
Exactly. So you see as well these valleys here in the graph. So what happens there really is the force on the packing is very low. There is leakage. And what happens there is there is leakage, and when you have solids in the fluid, actually these solids, they embed themselves in the packing and cause even more additional wear on the packing and shortening the life of the packing even further.
Do I understand that correctly? This is, for example, this is a shaft here, for example.
Yes, that's a sleeve.
A sleeve then there, yeah, okay. And, suddenly, the packing is relaxing. There's solids going between the packing and the sleeve. You're tightening the packing again. The packing is pressing the solids against the sleeve. It works like sandpaper, doesn't it?
Exactly, and that's when you get this effect that you basically are wearing the shaft down.
Okay.
So the issue that you see on that graph is really very maintenance intensive, and you have these peaks and these valleys. So what you really ideally would like to have is create a constant force on the packing.
So how can the amp unit help to get there?
Exactly, and that's where the amps comes in. So the ideal situation is that you have a constant force on the packing without all this maintenance, without all these peaks, and without all these valleys. And that's where the amps really comes in. And you see a picture of the amps here. So amps, really the advanced mechanical packing system, consists of a number of pneumatic actuators that are placed on each gland bolt. So each gland bolt has one of these units, and they are interconnected pneumatically to an air supply, so that as well the force in each unit is constant. So and in essence, what they do is they supply a continuous, constant force to the packing.
So that means, if I understand correctly, I have this amp unit. It means the amp unit itself is actually, it's not only one piece. You actually have them all around the shaft.
Correct, yeah.
Depending on the bigger size of the shaft, you have more or less of these amp units to actually cover provide a unique force onto the packing itself.
Correct. So if you have 2 gland bolts, you have 2 of these units, and if you have 4 gland bolts, for example, you have 4 of these units, depending on the number of bolts.
Okay. And you said, there's a pneumatic pressure building up. That means in the pneumatic air, the pressure comes in here.
Yeah.
And you have it on both sides because you connect the arms together so that, you always have a unique pressure then.
Correct. That's correct.
Okay. Let me ask you a question. How do you get the pressure, the pneumatic pressure?
Yes. The pressure can be supplied by using plant air. So the standard compressed air in the plant.
The normal air in a plant, 6 bars, 7 bars, whatever they have.
Yeah, absolutely. If you're in a location, for example, outside, you have a pump remotely, and there's no plant air available, then you can use as well an air bottle. or a nitrogen bottle, for example.
Like a gas bottle.
Gas bottle.
Why would you use nitrogen?
Nitrogen, first of all, is an inert gas, and as well the molecules are relatively large, so that's what we recommend for this.
Theoretically, you could use other pressure, but nitrogen is really, probably the best solution, so that you actually also have health and safety concerns. Are there not? Because nitrogen is inert.
Exactly.
How much gas bottles would you need to install one of these units?
Good question. Actually, the air usage, the gas usage of these units is very, very low. So typically, during the installation of the packing, so when you start to run in the packing, about 15 liters of gas is used. But during the life of the pump, when the pump is once running, really the air pressure or the gas pressure is only used to keep the force on the packing set.
Oh, I see. It means when you talk about 15 liters of gas, you talk about, in the compressed bottle, it's less than 1 liter of actually liquid.
Yes.
Reduced. That means the bottle will last for a very, very long time.
Yeah. So there's a very low gas usage.
So it means you could actually, if you have several rotating equipments nearby, you could use one bottle for several equipments.
Correct.
Okay, that sounds good. And coming back to the pneumatic supply in a industry, like you have your standard 7 bars system there in the industry, you have a compressor, everything in there. So playing devil advocate, what if a truck drives over the pipes on the pipe breaks, and suddenly the pneumatic pressure supply is actually disconnected, what will happen to the equipment here?
Yeah, so when that happens, and that happens, we all know that can happen, then in essence the force on the packing is lost. So
means it goes down again on there.
Yeah, and then you get a leak. So what we also have as an option to supply, and that's what we really recommend when using plant air, is we provide a buffer tank with a check valve that will always at all times maintain the pressure on the system. So you always have force on the AMS unit.
That's your safety device.
That's in essence a safety device that we
very good
provide.
So Chester provides actually the equipment. So it means if the customer can choose what equipment you need for the rotating equipment, the AMS, a pressure system then there, so that the pressure can be kept up when something goes wrong. Yeah, it means everything can be supplied by Chester.
Correct. What we supply is really the AMS units, the interconnecting piping, pressure regulator, buffer tank, control cabinet. We provide a complete solution that can be installed.
When you talk about control cabinet, what do you mean with the control cabinet?
So that's really, we can provide a cabinet where you have the buffer tank installed, where you have the pressure regulators installed, a check valve, a pressure meter, things like that.
Very, very good. It means you actually can remotely set the pressure onto the AMS system.
Correct.
That's very, very good.
And that's one of the other advantages of AMS. It's not only reduction of maintenance and extending the life of the packing. It's really as well operator safety. So nobody needs to actually go near the rotating shaft to adjust the packing set. It can all be done remotely.
Okay, very good. This unit is quite heavy. What is it made of?
Yes, the metal components of the AMS units are made from 316 stainless steel. There are some O-rings in there to seal the pistons. They are made from Viton. What we have as well is to protect the components. We provide a dust cap that will be placed on top of this.
To protect everything in between here.
Yes, exactly.
Okay, so that if there's possibly dirt comes, it doesn't get actually in between, so that
Correct.
The movement is always free.
Yeah, so and that's this dust cap that we supply as well.
Okay, and that is just a standard material then there's which is being placed over the
Yes.
unit like this.
Yes,
So it protects everything on the moving parts
Correct.
of this AMP unit.
absolutely.
So and how do you install this equipment?
Yeah, so really, when we install an AMS unit or the AMS units in combination with packing, we start with installing the packing in exactly the same way as we're used to. So we have our cut rings and we stagger the joints. We make sure that we tamp each ring to the bottom of the stuffing box. And when all the rings are installed, we put the gland on top. And then we really install the AMS units on the bolts interconnect the piping.
So
Yeah.
just give me, when I understand right, the operator is still putting the packing, in,
Yeah.
putting the gland on top of that.
Yeah.
That means the process, the procedure the operator is going through
Yeah.
will not change.
No, will not change.
Means it's actually very easy for the operator actually to follow through
Correct.
the sealing process, to follow through, the repacking process. The only difference is that on top of that, you place this amp unit.
Correct. So when you have installed these amp units on top of the gland, really you tighten the bolts or the nuts hand tight, making sure that the gland is perpendicular to the shaft, and then you leave it alone. So all the tightening of the packing can be done with the amp unit. So the initial running in of the packing, it's all done with the amps unit. So we don't need to be near the rotating shaft at all.
Means you actually place the amps unit onto the gland. You put the bolt in between, in the hole here, so that actually you can tighten the unit, with the equipment, with the rotating equipment.
Yeah.
So when you put gas pressure here, it tends to pull up the amp unit. But because the bolt is actually there, it will restrict the going up. Therefore, the whole unit actually goes down.
Exactly.
And put pressure onto the gland and onto the packing itself. And there.
Correct.
It's actually quite simple solution, but very effective.
It's a very simple solution. Yes.
That's amazing. So that means, if we have this now, do you have any experience, with this amp unit already?
Yes, absolutely. We really installed these amps units already in different industries. So, for example, in the sugar industry, pulp and paper, but as well in the hydro turbines. And I just want to show an example here of a hydro turbine that we installed our amp system on. This is a hydro turbine in Canada. And this is really a really old system. It's almost 100 years old. So it's a very old hydro turbine.
You talk about 100 years old plant or 100 years old hydro turbine?
The whole system is almost 100 years old.
The hydro turbine is that old?
I'm sure there are some components have been replaced in that 100 years, but it's really a very old system.
Okay.
So and the issue they really had is that the operator needed to frequently retighten the packing because of leakage, right? And what happened is really the operator needed to go down to the stuffing box and retighten the packing. But because of safety reasons, the turbine had to be stopped to retighten the packing.
I can imagine, when you stop a turbine, it has some after effects as well, or you need to prepare to stop a turbine. Is that correct?
Absolutely. The turbine is providing electricity to the grid, and this has to be prepared. So it was a very costly operation to do this every time because of maintenance, but as well because you're not basically generating electricity and making money, right?
Absolutely, absolutely.
So so that issue had to be solved, and our colleague, our specialist in Canada, he basically proposed to the plant to install a system, a combination of our dual pack 2212 packing in combination with amps.
Can you help me? What is dual pack?
Dual pack. I have a sample here, and you can see it on the picture as well. I have to explain the dual pack a little bit because this is really another innovation of Chesterton. If you look at traditional compression packing, it has four. If you look at the cross sections, it has four sides, right?
Correct. Yeah.
But really, only one of those sides has to be a dynamic seal. Has the function of dynamic sealing.
Because it only one side actually gets in contact with the rotating equipment.
Exactly. But traditional packing is always symmetrically made from the same material or the same materials. So you always have to find in the materials a compromise between static sealing, other properties, and dynamic sealing.
Means, when you have a graphite packing, you have four sides of graphite.
Exactly.
When you have a PTFE packing, you have four sides of PTFE.
Yeah.
Okay.
So Chesterton invented a new braiding technique where we are really able to put a different material on the shaft side and on the outside. So what we did with our dual pack 2212 is we put on the outside a para-aramid fiber. And para-aramid is a very strong fiber. Probably it's more or less 8 times as strong as steel. It's, for example, used in bulletproof vests.
Okay.
And when you braid this stiff fiber into a packing, it really becomes a very resilient and springy structure.
Is it like a backbone? You know, like
Yeah.
a support material?
Yes. So, and it's very strong as well. So it's very hard to extrude, and it gives you like a good basis for sealing. So, and on the inside, we used a meta-aramid fiber. Meta-aramid is, for example, used in Formula One racing suits.
Oh, okay.
So it's very fire resistant, heat resistant. It's non-abrasive and very ideal to seal shafts. So that combination was used for this hydro turbine.
And the white part, you know, provides also some lubrication.
The complete packing is completely impregnated with lubricant.
Oh, fantastic.
Yeah.
Fantastic. It means you have the tough backbone on the outside, on the static side. You have this softer lubricating part on the rotating side.
Yeah.
And why is it so unique? Why is this very unique?
This packing is very unique because, in essence, it's an invention from Chester, and we have a patent on this braiding technology.
It's because of the braiding technology, you know, that you can actually combine two different types of fibers.
Correct. So, and that in combination with the AMS unit, and it really reduced all the retightening of the packing set that needed to be done in that hydro turbine to practically zero. And as well, the life of the packing was extended to at least 2 times.
Okay.
So there were a lot of advantages for the customer. So they didn't need to stop the plant anymore. They had a strong reduction in maintenance because they didn't need to go down to retighten the packing as much. And as well, it was an increase in operator safety.
I guess, you know, when you do not have to shut down the plant to retighten the packing, the plant is also saving a lot of money because they can produce in the meantime. There's no unscheduled shutdown or no scheduled shutdown for just doing that job then there.
Yeah, so the savings here were really tens of thousands of dollars per month.
Absolutely, I can see that.
Yeah.
But at some stage, the packing will wear out as well. You said, you know, you can double or maybe triple even the lifetime of the packing, but at some stage, the packing will wear out.
Correct. So the packing stays the packing. The only thing we're really changing is the method of tightening. So packing will wear out at a certain time, and then the packing needs to be replaced, of course, as you would do when you wouldn't have installed the AMS.
Okay, but what happens with the AMS then when you replace the packing?
So the AMS units can be reused.
Are you serious?
Continuously. So this is really, the packing would be really the wear part in that system, and the AMS can be reused. Indefinitely, I wouldn't say, but for the life of the equipment.
You're actually serious. You actually, when you buy the AMS unit, you actually buy it for the equipment life, whatever the equipment is, 20 years, 40 years.
Yeah.
In your case, you know, the hydro turbine, 100 years.
Correct.
You know, theoretically, you know, the AMS can actually last that long as well.
Yeah.
You might only have to replace a couple of O-rings maybe after a couple of years.
Correct.
So
Exactly.
That's amazing. That means it's an investment for the lifetime.
Exactly.
That's very, very, very good. Just if I'm the operator now.
Yeah.
So, and I would be interested in improving my equipment,
Yeah.
increasing the lifetime of the equipment,
Yeah.
reducing unscheduled shutdowns.
Yeah.
Give me 2 or 3 points
Yeah.
why the AMP unit should be actually the solution for me.
Yeah. So really, if you're an operator of rotating equipment that is sealed with packing, and where packing is really the best available technology, be it for technical reasons or be it for economical reasons, then with AMS you can really reduce the retightening, so the maintenance involved in retightening packing, to practically zero. And as well, you can extend the MTBR, the mean time between repair of the equipment or the replacement of the packing. You can double that or even triple that. That is really those are really the reasons to install AMS. But as well, if to tighten packing next to a rotating shaft that can, for example, be leaking with hazardous fluids or just rotating shafts in general, they are very dangerous to be near. So if you install AMS, you don't actually need to be near that rotating shaft anymore. So it's as well a safety increase for plant personnel.
That's it. No, for me as an operator, you would have convinced me. I must say it's very, very exciting equipment. The only thing I would say as an operator is, why was it not invented earlier? It's really, this is a fantastic unit. I could have used it for years to improve my equipment.
Yeah.
It's really, really great unit.
Yeah.
Hans, thanks a million for giving us some insight on this equipment, and I really enjoyed the time. I learned a lot, and I hope you learned a lot as well about the new AMS system. Hans will be here if you have any questions about the new system, how to install it, what features it will have. Please send us your questions in, and Hans will be delighted to answer them later on.
Yeah, it will be a pleasure. And thank you very much for joining.
Thank you.
Thank you. Bye.